In this video, I'm going to demonstrate how to find the volume of a pyramid using the slicing method. In this particular case, our pyramid has a height of 24 meters and a rectangular base which has a dimension of 8 meters by 12 meters. So let's start by drawing a picture. So we have a rectangular base that perhaps looks something like this. And we're going up to a point. Okay, so there's my beautiful pyramid. And so this would be 12 meters, 8 meters, and the height is 24 meters. Now the key to this is finding a formula for a sub x. Because as we have learned, the volume is going to be approximated by the integral from a to b of the cross-sectional area times dx. So the key is we need to find a formula for the cross-sectional area. Well, the cross-sectional area is the base, okay? And the base is 8 by 12, but the base is constantly changing. As we move up the pyramid, the base will be getting smaller and smaller and smaller and smaller. So we need to find a general formula for that. And to do that, we will once again use similar triangles. So in general, let's say that the length or the area of the base is going to be base 1 times base 2, the length of the two different bases. And for the bottom of the pyramid, that would be 8 times 12. And so let's find a formula for B1. Okay, so B1, let's call this B1 right here. And let's call this B2. So for B1, we're looking at it from the side. So we'd be looking at it from the right-hand side or the left-hand side. The bottom is 8. And of course, the height is 24. And we want to find a formula for as we decrease to any value of x for the height. So this distance here is going to be x, and this distance here is going to be my B1. So the base in reference to some value of x, we have similar triangles. We can say that B sub 1 is to x as 8 is to 24, or B1 is equal to 1/3 x. Likewise, we can do the same thing for B sub 2. In this case, what we have to do is change this to a 12. We still have a height of 24. And we will still make this be a distance x, and this time we will have this be B2. And once again, we use similar triangles, so B2 is to x as 12 is to 24, which then becomes B sub 2 is 1/2 x. All right, so now that we have a formula in terms of x for B sub 1 and B sub 2, we can then say, okay, then our area, which we said is going to be B1 times B2, is now 1/3 x times 1/2 x, which would be, of course, 1/6 x squared. And then our integral for volume is the integral from a to b, which would be from 0 to the height, which is 24, of a sub x, which is 1/6 x squared dx. And there is our integral. All we need to do to finish the problem is integrate that. So the volume would be 1/6 times 1/3 x cubed, evaluated from 0 to 24, or 1/18 x cubed from 0 to 24, which becomes 1/18 times 24 cubed, which using a calculator comes out to be 768, and this would be cubic meters. And there is the volume of our pyramid.